Okay, just finishing up this problem. We're supposed to draw in the velocity vector at the point 4, 0. Recapping, we looked at the point 4, 0. We saw that that corresponds to t equaling pi over 2. So tell you what, I would like to actually find v of pi over 2, and working that up from up above, that is the vector 4 times the cosine of pi over 2, comma, negative 2 times the sine of pi over 2. Simplifying, we know that the cosine of pi over 2 is 0. 0 times anything is 0 itself. Sine of pi over 2 is 1, so negative 2 times 1 is negative 2. Well, that's your velocity vector, but we're drawing that in at the point 4, 0. 0, negative 2, we would envision starting at the origin and going 2 steps down below. We're going to essentially have that occur right here. The magnitude of this velocity vector is in fact a 2. We could use the Pythagorean theorem on this vector of 0, negative 2. Of course, I think you can see plainly that the length is 2 more directly. But that's what a velocity vector would look like. And it's communicating not just the speed, but also the direction when the particle would be at 4, 0, or similarly when the particle is at t equals pi over 2. I think it's important to also have a little bit of a tie-in to talk briefly about how this is not the exact same thing as finding a tangent line slope. The tangent line slope we could find parametrically. I hope you can see that it would be an undefined tangent line slope. What we're seeing is just because a tangent line might be undefined at a particular point on a curve, that does not mean that our velocity is undefined. Quite the opposite. Our velocity is defined and we do have a speed. So just letting you know how we can make some connections in the future. So sorry for the interruption before. We had a bell ringing and that interrupted the recording. So that wraps up this lesson. Just one more to go and then we're done with the BC curriculum. Best of luck.